In section 2, we're going to be talking about the slope of a line. And slope is something we have already talked about a little bit this year. Way back, chapter 5, we counted slope off of graphs. And we did it by starting at one point and counting up or down, then to the right, and it was a fraction. Okay, it's a measure of how steep a line is. Now we're going to make it a little bit more formal. So I'm going to give you an equation. And that equation says m, which we use m for slope, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay. These x's and y's have subscripts because there are two x's and two y's, and we have to differentiate between them somehow. We can't just put y minus y over x minus x. That would be 0 over 0, and that doesn't help anybody. So what this is saying is if I give you two ordered pairs, to get the slope, we take the y value from the second ordered pair, subtract the y value from the first ordered pair on the top. In the denominator, we take the x value from the second ordered pair and subtract the x value from the first ordered pair. We'll get into doing some of that in a minute. There are essentially four different types or flavors of slope. Okay, a positive slope is what you get off of a line that goes up from left to right. A negative slope comes from a line that goes down from left to right. Horizontal lines, flat, straight across, have zero slope. Okay, they have a slope, it's the number 0. Vertical lines, straight up and down, do not have a slope. We call it undefined. You cannot say no slope. You must tell me it is undefined. Okay? Mathematically, uphill and downhill, those just come out of the equation normally. Horizontal, a 0 slope, comes out of our equation with 0 in the numerator. And a vertical line would come about when we have a 0 in the denominator. So, find the slope passing through each pair of points. This is a little bit of math. So, we take the y values on the top, x values on the bottom. So, let's see. Second y value minus first y value on top of second x value minus first x value. Okay, look at how I did that. 1 minus 5, y2 minus y1 over 8 minus 2, x2 minus x1. If anything's going to catch you here, that's what it's going to be, putting those numbers in order. Because now you're just talking basic, good old-fashioned arithmetic. 1 minus 5 is negative 4. 8 minus 2 is 6. And that simplifies to negative 2/3. Let's do it again. So here I'm going to have 6 and negative 3 being my y values. I'm going to have 4 and negative 2 being my x values. So y2 minus y1 in the numerator is going to be 6 minus negative 3. Yes, we'll talk about that in a second. And in the denominator, I'm going to have 4 minus negative 2. And I hope most of you are like cringing when you look at this and going, Mr. Noy, no, we don't do minus negative. You're right, we need to change those to pluses. So we really have 6 plus 3 over 4 plus 2. Okay. Now we can just go normally. 6 plus 3 is 9. 4 plus 2 is 6. That reduces to 3 over 2. And stop there. Do not make this 1 and 1/2. Don't make it 1.5. You want slope to be a fraction. period. Not a decimal, not a mixed number. Improper fractions are fine. The slope of this between these ordered pairs is 3/2. Leave it as 3/2. The next bit we did in chapter 5. So I'm not going to spend too much time hanging out here. So determine the slope. So to get from the point on the left to the point on the right here, I go up 3, right 2, which means the slope is 3/2. I'm betting most of you are going, oh yeah, I remember this. On my other graph, if it draws, I'm going up 2, right 3, so the slope is 2/3. Okay, nothing new there. Something else from chapter 5. Parallel lines have the same slope. I think you can tell if two things are the same. And perpendicular lines have slopes that are negative reciprocals. Something like, 2/3 and -3/2. So we're going to tell whether the line passing through these points are parallel or perpendicular. So let's see. I need to first break this in half. And let's see. Slope of line 1. Okay, little subscript 1 on this M to say this is the slope of the first line. Y2, that's 5. Minus Y1, that's 9. Over X2, that's -1, minus X1, which is 1. No minus negatives to change into addition here, so we can just go ahead and do the arithmetic. 5 minus 9 is -4. -1 minus 1 is -2. So the slope of line 1, when it's all said and done, is 2. You could report that as 2/1 if you want. I won't mark it wrong. But you do have to reduce it at least to 2/1. So first line has a slope of 2. Slope of the second line. Y2, that's 9. Minus Y1, so minus -5. Over X2, which is 4, minus X1, so minus -3. Again, all these minus negatives are hanging out, so we've got to make those all addition. So it's going to be 9 plus 5 over 4 plus 3. 9 plus 5 is 14. 4 plus 3 is 7. 14 divided by 7, the slope is 2. Those are exactly the same. 2 is 2. So these guys are parallel. Stands to reason, you know how I do notes. The next set are probably going to be perpendicular, but let's check that. So slope of line 1. Y2 is 6, minus Y1 is 0. X1 is 20, minus -10. 6 minus 0 is 6. 20 minus -10, we know that's 20 plus 10. So that's 6/30. You should simplify that. The slope of my first line is 1/5. Let's check out slope of line 2. That's going to be -11 minus 4 over 2 minus -1. -11 minus 4 we can do. That's -15. 2 minus -1 we have to change into 2 plus 1 before we can do it. So we get -15 over 3. So the slope of the second line is -5. Are these the same? Obviously not. Are they negative reciprocals? Well, let's see. One is positive, one is negative. We need that. Are they reciprocals, flips of each other? 1/5 and 5. Yes, they are. These are perpendicular. And yeah, I'm not writing that out. So, last bit here is going to be graphing with this information. So, if I give you a point and a slope, all you have to do is plot the point. So 1, 1, right one, up one, point. Count the slope off. Okay, here the slope is negative 1/3. Negative means go down. And remember, slope is rise over run. So down 1, right 3. Down 1, right 3 from where we started is over here at 0, 4. Or rather 4, 0. And we would connect those. Once again, I'm probably not going to require that you do the graphing problems because of potential lack of coordinate plane paper. If you can print it and you can practice it, I'd recommend it, but I'm probably not going to force you to do it. On a quiz, would I ask you a question about this? Yes. How would you answer? You would describe the process to me. So you see where I've got my steps? If this were a quiz and I were asking you to tell me how you do this, since you can't actually do it for me, you would literally say, plot 1, 1. From there, ooh, my writing is really bad. Count down 1, right 3. That would tell me you know how to plot the point and do that first, and you know how to use a slope. So in terms of a quiz, this is what you'll have to do. You'll have to describe to me how you would plot this graph.